We're going to do a question on crack analysis. So the specimen would be in kind of a fatigue tester being tested between 0 and 16 megapascals. And it has to withstand 2.5 by 10 to the 5 cycles. And there's presence of an elliptical crack. So in the question they give y is equal to 1 for this. And then they also give three different values. So KIC, which would be the crack intensity factor, or the critical crack intensity factor, which is 1.9 megapascals square meters, which is just the unit for crack intensity factor. And then N is 3.3, C is 2.5 by 10 to the minus 6. So N and C are just two constants that can be found from testing the material. And then the first actual question is to show the number of cycles to failure for the above is equal to that equation down below. And then the second question is, what's the initial flaw size that can be tolerated so that the material can perform as normal? So to derive the equation, we have to use Paris law. This is kind of the first of Paris's law. So it says that the crack intensity factor is equal to y, which is a number in this question is given as 1, but I believe it's a number based on the dimensions of the specimen in like height and width and thickness. This would be the stress that's undergoing in the fatigue testing, and then it's multiplied by the square root of pi, and then A, which is the crack length. It's also good to know that sometimes in a specimen, the crack length or the crack length can be 2A. So that at the end of the second part of the question, we're just going to be finding A and multiplying it by 2. So this is the first equation. So this can be changed to the change in the stress intensity factor is based on the change in the stress that's being put on the specimen. So that's the first equation. Second one, the change of the crack length per cycle, and that's equal to C, which is a constant that was given, multiplied by K to the power of N, which is also given. So these are our two equations that we start off with to derive this, and we're going to now, for the next step, put the delta K in here. So then we have this. So if you want to just keep referring back to the original question, just so that you can compare what I'm trying to do here with what the actual question was. So what I'm going to do here is I'm going to bring dn to one side, like was in the question, and I'm going to bring all this down here. So the next step. Sorry, I forgot the whole time to put in the n. Okay, so you can see that it's already kind of semi-starting to look like the answer. Okay, so the next step is just to break this out, make it look more presentable, so I'm just going to put it over here. So the y is not in the question, and it's equal to 1. So at this point I'm just going to drop it, okay? Because it's going to be equal to 1, it's not going to have any effect on any of the results, so I'm going to drop that. I'm going to change the square root of pi to the power of a half, and I'm going to do the same with the a, except I'm going to take it out of the bracket, and understanding that it's already to the power of n, I'm going to break it up, so I'm going to have it outside the bracket. So this is going to be the same, and I'm just going to have a outside the bracket, and it's going to be a to the minus n over 2. Now I kind of skipped a step there. So I changed the sign on this because I would have been multiplying 1 over a to the power of n over 2, and once you go above the line, once you start changing the whether you're above or below the line, you're also going to change the sign on the power. So the next step now is to try and look at these dn and the dA and try and integrate. So for the dn, we're going to have the upper being the number of cycles, which we're going to say is nf, and the initial number of cycles, which is 0. So that makes it easy. And then for dA, which is crack size, we're going to have the initial crack size and the final crack size. So the final crack size is the critical crack size, the crack length that's going to cause instantaneous breakage of the material. So now we start integrating. So I'm going to not put in the upper and lower limits into this. I'm just going to keep them as normal. So dn turns to n. We have critical, initial, on the lower we have the same. When we're looking at a to the power of something, so in the integration you add on 1 to whatever the power is, and then you divide by what the new power is. So in this circumstance we're going to have a 1 minus n over 2, and then we're also going to have that multiplied by 1 over 1 minus n over 2. And then the dA is going to turn into a 1. Changing what you see here to what the end question is, a lot of it is just manipulating this. So basically what you're doing is you want to get a 2 on the top to change, because on the answer there's a 2 on the top here, and there's also 2 minus n on the bottom. So we're going to try and change this to that. So I'll just kind of take this over here. So the 1 minus n over 2 is also equal to 2 over 2 minus n over 2. So I just use kind of commas to change as if I'm going to the next line. So then you have 1 over 2 minus n over 2, and as you know, you take the bottom fraction, flip, multiply, and then that gives us 2 over 2 minus n. So now that we know that what's here is actually what's in here, you can multiply this by the equation we have here. So the 2 minus n will slot in down on the bottom, and the 2 will slot in on the top, so that makes it look a lot nicer. So that's basically all of this bit done. Now we're just looking at this bit. NF minus 0. I'm not even going to bother. We have, to break this out, it's going to be AC 1 minus this, and then take away AI. Okay, so this is the first answer. So now we're going to try and solve the second part of the question. So we have Paris formula, which says that the critical crack intensity factor is equal to y multiplied by stress AC pi. So we have my logic of, like, the way I was thinking here is that if you look at the equation, we have all the variables that we need to just throw it into the equation, and by the equation I mean the equation that we solved in part 1. So the only variable we don't have is the critical crack size. So now we have to try and find A on its own. So we have KIC divided by Y, and then squared, and so and then that's equal to AC. So when we input the values, we get 1.9 divided by 1 and 16. When we work that out, we have 0.0044 meters. So now that's our critical crack size that we can put into the equation that we solved in part 1. So now this is the equation we found at the end of part 1. So I'm going to put all the values into it now. It's a bit of a mess on the calculator, but I just break it up into sections. So I do, this calculation here, and then this calculation, multiply this by this, say, and then multiply that by this. So then I'm going to have to bring it down here. So out of all this mess, we want to find AI. So we're going to do that in kind of sections. So the next step is going to be below this line. So we're still going to have 2.5 by 10 to the 5 cycles, and when this is all calculated out, we end up getting minus 9.8913, and then when this is worked out, it ends up being 34.025 minus AI to the power of 1 over 3.3 over 2. You can break this power down as well, and you can find out that it's actually equal to minus 13 over 20. So I'm going to take this number divided by minus 9.8913, and then take away 34.025, input that in the calculator, and you end up getting and you end up getting 25,308 which is equal to AC. Oh yeah, and you change the sign just to turn the AC into, or sorry, AI into a positive. And then it's minus 13/20. So I'm only changing the 1 minus 3.3/2, but if you put that in a calculator, it ends up to be minus 13/20. Root of this number, and just throwing this to the other side, so you square root the both sides by, or sorry, not, yeah, by this number. You root both sides by that number. And then you come out with this value in meters for the initial crack size, but you have to multiply it by 2 because of there being 2A in the actual crack length. So then this would be the answer for part 2.